Swayam Prabha. Digital India. Educated India.
You know, he did a wonderful job on 2 counts. Number 1, I think he taught you well because I learnt a lot along with you. And number 2, teaching for 3 hours at a stretch is no joke. You try it out. Teaching for 3 hours at a stretch is absolutely no joke. And then doing that consecutively on Friday and on Saturday. So he deserves another round of applause, please. Thank you. So he'll be seeing you again on this Friday and this Saturday. Ria, can you hear me? Can you hear me? Okay. So he'll be seeing you again on this Friday and this Saturday with one of the problems that you're going to be solving with AutoCAD based on the experience that you have had the previous week. Okay? So, you know, I was looking at certain documents and I dug this thing out. Do you know what this is? Do you know what this is? Huh? What? Identity card? It says Indian Institute of Technology, Bombay, and incidentally it has my name here. And this is something that you're going to be getting 4 years down the line when you're graduating. So this is my graduating degree, BTech IIT Bombay. Well, somebody told me that I need this to get my passport renewed tomorrow. So I'm going to take it along with me. Anyhow, let's get started. If you recall, quite a few lectures ago, we had dealt with this problem. So we had this cube, which was FCC'd on all sides, 6 sides, and there was a BCC void within the cube. Okay, you recall that? Okay. So the front, top, and profile views were identical, and in none of the views you could realize any information, or you could know, or you could learn any information about the void that was within the cube, within the big cube. So there are ways to come around it, and we are going to be discussing one of these ways today. Section and assembly views. Okay. So that was one of the motivations. This is the second motivation that I'm going to be talking about. So let's draw a problem which is very similar to question 1 of your 4th homework. So let me start with the top view. So you have 2 lines, 2 semicircles on the left, on the right in the top view, a bunch of circles with center lines. I'm going to talk about this feature in a while, okay? And then you have some supporting structures called ribs, which I'm going to talk about today. So let me start drawing the front view of this. Okay? You see a rectangle. Take the projections of these cylindrical feature down. Okay? This is the cylindrical feature. Take the projections down. So if you realize, you have this hole which is a through hole. Okay, it's going from top to bottom of the object, and then you have some like this. Okay, this feature, and I want your attention here because this is something that I'm going to be asking you in the exam. This feature is called a countersunk. Okay, countersunk, COUNTERSUNK, countersunk. Okay. What I will give you as information is this: countersunk, phi something deep, comma, phi something through. Okay, once again, countersunk, diameter something, some distance deep, DEEP, and then space or comma, phi something through. Okay, so this describes this entire feature. We'll continue with the projections, and we'll start drawing hidden lines pertaining to the circular voids in the top view. Okay, something that should be familiar to you because you have drawn this in your homework problem. I'm going to go slow so that you realize what's going on. Alright, so at this time you see these hidden lines pertaining to these circular voids here. Okay, hidden lines pertaining to these circular voids, and then the corresponding center lines. The same on the right hand side, hidden lines pertaining to these voids, and then the center lines. Okay, and then this is a triangular rib, RIB. This is a triangular rib. The corresponding projection here on the top view. Likewise, you would see something very similar on the right hand side. So there are ribs on top and bottom in the top view, and correspondingly you will be seeing those structures in the front view. This is, of course, the third angle projection. Okay, question 1, is this technically correct? Yes or no? Huh? No? Yes? Maybe? Assuming that I have not made a mistake. If you assume that I have not made a mistake, is this technically correct? Yes or no? No? Yeah?
For that upper part, would there be 3 circles or 4 circles?
This one? Yeah, looks like there would be 3. Looks like there will be 3. Fine. So ignore this circle for the time being. Ignore this part for the time being. Okay.
There should not be one more circle.
There should be or there should not be?
There should be one more circle.
There should be one more circle. There should not be one more circle. Okay, projection 1, projection 2, projection 3. Ha, you had me there for a while. Huh?
In isometric, we will see 4 circles.
In isometric? You've drawn it, right? Okay. So in the top view, you will see 3 of these. So the innermost part corresponds to this through hole. Folks, can I have your eyes on the screen, please? So the innermost circle corresponds to this, the middle circle corresponds to this, and the outer circle corresponds to this. Okay? Technically correct? No? Yes, okay. Question 2. Are you happy with the front view? Why is that? Huh? It's difficult to distinguish which hidden line corresponds to which feature in the top view. So too many hidden lines? Yes? No? Too many center lines? The front view is confusing? Yeah? Can you do something better? Perhaps. Okay, so we discussed all these reasons. And of course, hidden lines, center lines, all those lines, projection lines, many lines, they create a lot of confusion. Okay? What do we do about this? Very simple trick. Very simple trick. Divide and conquer. Works everywhere. Yeah? Divide and conquer. So what we are going to do is we are going to take a knife. Okay? Section the object so that the top view is sectioned. Okay? This is your section line. This is how the section is depicted by convention. Take the bottom part out and view the object in this direction. Okay? Once again, take a knife, cut the object into two different pieces. Okay? By convention, this is how we represent the cutting operation. Okay? We let go of the bottom part of the top view and we look at the object from this direction. Okay? Of course, there will be certain changes in the front view and we'll try to figure what. Projection lines back. I want you guys to be very careful and follow me. Okay? Now that we have done this, there is one thing that I would actually want you guys to keep in mind. I would not want to show in my front view any hidden feature. Okay? So long as you keep this rule in mind, it's okay. I would not want you guys, or me for that matter, to show any hidden feature. Okay? Having said that, let's continue. What do you see? Do you see this line as solid line? It's basically, what you have done is you have cut the cylindrical void into half. So essentially, this would represent one of the boundaries of that cylindrical void, of this one in particular. Do you see this line? Yeah? Okay. As I said, I'm going to be ignoring this cylindrical void because it's essentially hidden. I don't want to be showing the hidden features. Likewise, I'm going to be ignoring this cylindrical void. I would actually want to show what I see. Okay? What I see. Do I see this line as a solid line? Yes? This thing is cut. Do I see this line? This thing is cut. Do I see this line? Yes or no? Yes. Good. Do I see this line? Do I see this line? Do I see you? I do. Do I see this rib now? Because that part is gone. Okay, that part is gone with the part of the top view that was here. Okay. Again, I'm going to be letting go of these hidden lines because they correspond to the cylindrical void at the back here. Stay with me. Would I see this line? This line? These guys gone? Okay. The corresponding center line's gone. Okay. How about this line? How about this line? Would I see this or would I not see this? I won't see this. Okay? What's the difference? What's the difference? The front view is a lot more clearer now. Is it? Is it? Yeah? Vertical. You mean this line? This thing? I'll come to that. I'm so glad you guys are thinking. So far so good? To show that you have actually taken a section of the object. Okay? Once again, to show that you have actually taken the section of an object, this is the only part of shading that is permitted in technical drawing. Hatching. Okay? By convention, this is the only part of shading that is permitted in technical drawing. This essentially means that you have material here, no material here, okay, on the section plane, material here, no material here, material here. The triangles, I'll come to that. Okay, for now, of course you would agree that front view is much clearer. Okay, you would also realize that the entire information is not depicted. Okay, so I'm going to be making a statement here. Be careful. Section views are nothing but a trade-off between clarity and information. It's a compromise between clarity and information. Okay, if you want more clarity, let go of certain information. If you want less clarity, include as much information as you want. Okay? Something to keep in mind. However, it'll be a nice idea for you to show the full top view. Okay? So that much of information, not all, but much of information is something that you're able to retain. Okay? Section views is about relaxing, once again, relaxing rules of projection in favor of clarity. Okay? So this is how the section plane is shown. Okay? Top view. This is like the edge of knife. And you're looking at these two directions, okay? And the bottom view, in the front view, you say section AA, okay? Why did I not section the triangular ribs? You have no idea, and I expect that. Not a problem. I'll come back to it later, okay? But to give you a clue, by convention, there are certain elements in the object which are supposed to be for support. Okay? For example, these triangular ribs, they are essentially meant to support the cylindrical feature over this platform. Okay? This need not be there in the object. Okay? But since this is there, it's kind of ensuring that this cylindrical feature stays perpendicular to the base of the object. So it's a supporting element. It's not the machine part, but supporting element. It's called a rib. Okay? And later I'll tell you that there are certain supporting elements that you do not section. Okay? You just ignore that the section plane is passing through those supporting elements. It's called the full sectional view. Full sectional view. You're taking the entire section. Okay? There are different kinds of sectional views. The second one is the half section view. And for this example, you can take advantage of the symmetry in the object. Okay? Okay, again, it's a trade-off between clarity and information. You don't take the entire section, but you just cut 1/4 of the object. Take it off. Okay? The part on the left in the front view stays the same as if you're taking the front view of the entire object on the left. Okay? The part on the right is sectioned. Okay? From the top view, you realize that the object is symmetric. Okay? This is where you depict the entire information. This is where you depict the information after you have sectioned the object. Okay? Or the interior of the object. Right? Your top view will always remain full. Look at the way I have drawn the section line here. Dash, dot, dot, dash, dot, dot. Pretty much like the hinge line. Okay? You're the boss. You can choose the cutting plane in whichever way you want. Okay? It need not be straight. It can go zigzag. Okay? Depending on the details of information that you want to depict. For example, I can choose the cutting plane to be like this. Okay? Starts from here up till here, goes back, starts from here up till here. Okay? So the right part is actually showing the center part of the object, and the left part is also covering the features which are at the back of the rib. So you can choose the section plane you want. Okay? Take this part off and start drawing the front view. This is something that you have seen before. Let's start drawing the left hand side. The projection lines, you would see this. Would you see the edge? Fine. You would see this edge, of course. No? Yes? No? What's wrong? These guys should be and should not be hashed. Solid? This part should not be hashed. Yeah?
Section of the object. So if we consider the stand which is kept
It's called a rib. It's called a rib.
So when you are going to section it, that will be the same plane. So that vertical line and that small horizontal line will be visible.
So this line and this line would not be visible. Huh? Assuming that this is not there, would be visible then? Huh? So when you're sectioning, just assume that supporting elements are not there. Section and then add the supporting elements later. Okay? By convention. I'll talk about that a little more. Discussion time. Full section, half section, offset section. The fourth one is the revolved section. It's mainly used to show the cross section of elongated parts. Let's say if you have an object like this and if you want to show the cross section, this is an object where the front view and the top view, they are the same. Okay? Cut the object anywhere. Okay? And show the cross section within either the top view or the front view. Okay, likewise, the second example, this is like a T section. If you cut the object over here, this is like a T section, and the T section is going to look like this. Okay? So just to show some more details in the object. Revolved section. Removed section. It's very similar to the revolved section, just that if you want to show the cross section at any point of the object, show that section elsewhere. Cut the object, go down. Do not show the section with the front view itself, but slightly down or up. Okay? Okay? Likewise, for this also. This is important, and this is something that all of us follow or try to follow diligently. For clarity, standard parts are not sectioned even when cutting planes pass through them. Parts like shafts, nuts, bolts, ribs, spokes. I'm going to talk about webs and lugs. Different examples. This is an object with a rib and a lug. Okay? If you want to cut this object in two pieces, like so, you do not section the rib. You do not section the rib, and you do not section the lug. Okay? If you look at this carefully, if you let go of this object, you won't lose much. Sorry, if you let go of this part, you won't lose much. If you let go of this part, you won't lose much either. So they are not the main, or so to speak, defining features in this machine part. They're just supporting elements. They're just there. For example, this thing is to help, or this thing is to, in a way, ensure perpendicularity between the cylindrical feature and this platform. Okay, so it's just there. And let go of this. Okay, so won't matter much. Look at this example and look at the section view of this. Okay, so it's pretty much like, take the bolts out. Okay, listen to me very carefully. Take the bolts out. Take the shaft out. Okay, what you're going to be left with is this flange and this flange. Take the full section. So these are two parts. So this is the corresponding section for this flank, this is the corresponding section for this flank. Since there are two parts, they are hatched differently. Okay, 45 degrees from the right and 45 degrees from the left. Okay, once you have shown that section, then bring in the bolts back and the shaft back. Okay, with me? Yeah?
So how should we decide that the rib is not a major part of that object?
Think and analyze.
You can't say that we are connecting this with a coupler. Just take an example of that second one coupler. In that coupler, we are connecting two couplers with the help of that rib only. Then how can you connect the part?
Which coupler?
Second one.
This one?
Yeah.
Well, this is different from this.
Bolts cannot.
No, wait, this is different from this.
Yeah.
Okay. Yeah.
But instead of that nut and bolts, if I can connect both of them by pressing them and just by locking them with the ribs, then how can you say that it is not a
With the ribs, you can't lock them with the ribs. You can't fasten them with the ribs, can you?
Yes, I can lock.
With the ribs?
Yeah.
Okay. Okay. Well, by convention, elements which happen to be of supportive nature, elements which happen to be of fastening nature, okay, they are not sectioned. Okay, by convention. So two kinds of pulleys are shown over here. One is a pulley with solid web, okay, and one a pulley with spokes. Okay. So the one with solid web is sectioned, the web is sectioned, and in this case these spokes are not sectioned. Okay, so it's not so very easy to appreciate this when you are learning this for the first time. Okay, so you need some practice. And on my web page I have also uploaded a supporting document for you to kind of go through. Okay, so this lecture along with another supporting document. First example. Okay, so you have fasteners over here. Okay, so if your section plane is not passing through this, don't worry about that. Okay, just section it and show what you see. Okay, so this part is getting sectioned. This part is getting sectioned. Okay, so the black part, and so it is hashed in your drawing. The red part is not sectioned, so it remains white. Let me come to this example. Full section, half section, offset section, what? Full section. One slice. Yeah?
What he was telling that you can join the ribs without using the screws. If you have two ribs and a joint to the base,
Do you know what a rib is? Huh?
a triangular support like being
He's on time. He's not on time. Thank you. Part 1, part 2, they are supposed to be perpendicular. This part is called a rib. It's a triangular feature, it's called a rib. So if I take a section, I just take the rib off, take the section, hatch this platform and this platform, and then, so to speak, put this back. Okay? I cannot foresee how you can fasten two flanges with this rib. Okay. Or maybe on Thursday you make a model like you did last time. Okay. So this is what a rib is. Okay. Essentially is there to maintain perpendicularity between these two parts of the object. Okay. Full section, half section, quarter section, what? Full, half, quarter. This would be the full section. Half of that is half. Section. What? This would be the full section. Half of that is half. Okay? So even though I have taken the quarter of this object out, it's actually a half section. Now realize what I've done. I've taken the bolts out. I've taken away the bolts. Okay? Attach these guys together. Sectioned this part, sectioned this part. You can see these section lines, red and white. Okay? And then I have placed the bolts back. Okay? This is just for the sake of depiction. Because, see, if you start sectioning everything, it becomes very, very difficult to follow. You have to be clear in your drawings. That's one of the reasons why they don't section standard objects. Okay? All right? This is another part. What's this? Well, in layman's language, what I have done is I have taken a quarter of the object on the right out. I have retained the object on the left. I have not sectioned it. Okay? The bolt stays there. The shaft comes out. Okay? Maybe it also stays there. Okay? Shaft comes out. I section this part and then place the shaft back. Okay? This is how you're going to be sectioning your drawings. Right? Section the main parts. Section the main parts. Ignore the supporting elements. Okay? Ignore the fastening elements. Okay? The elements like ribs, spokes, lugs. Okay? Section the rest of the object and then bring those supporting elements back. Yeah? I'll have to scratch my head. I would say it's the half section of the right part of the object. Okay? Half section of the right part of the object. The left part is intact.
Is there any name for this type of section?
I would actually call it still a half section, but I would add some more information to differentiate between the fact that I'm taking the section of the entire thing or just one part. Okay? I would still call it a half section. All right, so aligned section. So if you realize, what we are doing is we are relaxing the projection rules. Okay? We are going more into clarity and we are letting go of certain information. Okay? So we are striking a trade-off between clarity and information. So this is another example where your projection rules are relaxed for better clarity. Okay? Features which are odd in number are rotated to align with the sectioning plane. Okay, let's say you have the top view of an object. It's circular. You have got 3 ribs. You've got 3 ribs, 1, 2, and 3 at 120 degrees, and you've got 3 circles through voids again at 120 degrees. This is the cylindrical feature. Okay. Let me try to draw the front view. So if I section this object like so, and if I try to look at what the front view looks like, I'll see a rectangle. So there's this hollow feature over here at the bottom of the disk. I'll take the projections. I'll get the cylindrical feature. Okay. I'll get this rib. Okay. And I'll get this hole. All right. Now look at the object. What's your first impression? What's your first impression? Yeah? Yeah? A second part of the second rib is also going to be visible. You mean this one? This one? Well, why not this one? The other one will be kind of hidden behind the front one, huh? What? This is the section. Oh, okay, fine. So this part is off. Of course, this one, yeah. Yeah?
So certain parts of a slight part of the rib should be visible from.
So what you're saying is whatever information that is left, you're trying to retrieve it now using projection rules. Yeah? Yeah? So you're going for that. You're going for that. So you're saying, fine, I mean, this rib is something that we have not shown. Okay, so let's use projections and try to show the rib. Yeah? How about this hole? What?
That's what he's saying that upper rib, the one that goes, that's above the section.
Yeah?
A certain part of that would be visible in this section. That's what he's saying.
Well, how? By projection, nah?
Behind that.
By projection, nah? So essentially you're going to be taking the... Guys, hold on. So what Kevin is saying is essentially you're going to be taking the projection lines over here and you're going to be trying to show the rib. Yeah? And likewise for the holes also, nah? For this hole. The hole won't be visible, okay? The rib will be visible. Okay? You'll be a wonderful teacher one day. Without the mic, of course. Do you sing? Do you sing? Okay. बहुत दम है. All right. Do you see some symmetry in the top view? Symmetry in some sense in the top view. In some sense. Huh? Okay? Alright. But if you take the projection of the rib, this will be in a way unsymmetric. No? Yes or no? Yeah? Alright, so this is the trick that people tend to follow. Okay? Follow very carefully. I'm going to be aligning. Once I do that, I get to show this section plane over here. This hole over here. Okay? Folks, I align this guy over here and I get to see this corresponding feature here, which is in symmetry with this. One thing. I do the same thing with the rib. I align it and I get to see this part. Okay? Okay? So I am relaxing my projection rules significantly over here. Okay? While in a way not compromising much on the information. In a way not compromising much on the information. With this alignment, I am able to show the true dimensions of a feature. Okay? Once I do that, I get to section. One more time. So far so good here? So far so good? Imagine that the hole travels up to this section plane and participates in the sectioning. Correspondingly, you'll see this hole over here. Likewise, imagine that the rib rotates itself to align with the section plane. You'll see this part. And then you section the rest. Okay? My projection rules are relaxed now in favor of information. Okay? This is how you show the aligned section. All right?